Hi, welcome to COMP501 Foundation of Programming. In this lecture, I will talk about recursion. You know that a function can call other function, and you've done that many times. But do you know a function can also call itself? When a function calls itself, this is called a recursive function. In recursion and iteration are similar because in order to use a recursion, the problem typically has some type of a repeated step. However, there are some problem can be solved either way. Some problem can be only solved using recursion, and there's some problem using recursion. It just makes things easier. It's easier to code and understand compared to the regular program that we have been writing. All recursive algorithm must obey three important laws. First, it must have a base case. This is like the while loop condition. The base case basically is how you get out the recursion. Once you hit the base case, that should not have a recursion, and that's how you get out the recursion. A recursive algorithm must change its state and move toward the base case. Just like in a while loop, the condition, the loop variable should change. Eventually, it will hit the condition where the while loop will be forced to get out. The recursion also the same. The algorithm must change the state such that you will move toward the base case, and once you hit the base case, it will no longer does the recursion. And a recursive algorithm must call itself recursively. As I said earlier, base case is a condition that allows the algorithm to stop recursing. The base case typically is a problem small enough to solve trivially. It's a simple problem. You know the answer without doing anything. And we will talk about this when we see some example. And without the proper base case, you will have an infinite recursion, and the program will not work. Just say if your while loop condition is wrong, you're going to have an infinite loop, and the loop never exits. Same with the recursion. And again, for recursion, we must arrange for the change of state that move the algorithm toward the base case. A change of state would mean your data, some data that the algorithm using is modified. Usually, the data represent our problem gets smaller in some way. Eventually, it's small enough become the base case. And finally, again, the recursive algorithm must call itself. Let's take a look at this problem here. Can you tell this is a recursive function? How? Can you identify the three recursion laws? First, all the recursive algorithm must have a base case. And when you do the recursion, a lot of time you're going to see if and else, where the if probably is the base case. So this is your base case. If count is 0, then I print go. Otherwise, I print count and then count down count minus 1. So if I call, and this tell you this is recursion because you call yourself, and take a look at this. You call countdown of 1. So I start at 2, you call countdown of 1, and you can see that if when I get to 0, which is the base case of count is 0, then you print go. That stops the recursion. So those are the three recursion laws that you see here. Base case, changing state right here. The count getting smaller, it call itself, and the count gets smaller, eventually it will hit the base case. So when I run this program, if you do this by hand, count down at 2, it can't equal to 0? No, so it will else print 2 and call countdown of 1. I call countdown of 1, it count is 0? No, so you print count. And then I call countdown of 0. So you count is 0? Yep. Then I print go. So if you look at this here, you can see it called countdown of 2, and then 2 go to countdown of 1, and then 1 go to countdown of 0. And that's when you stop the recursion. And let's see how this runs in the stem. So this is the countdown program. And let me add this. Call Python countdown 2-1 go as expected. What will happen if I add the print count here? What will happen if I add the print count here? If I run this program, this is the earlier output 2-1 go, and then now I have 1 and 2. Why is that? Where's the 1 and 2 come from? Well, let's take a look at this diagram here. I call countdown of 2, which print 2. Then I call countdown of 1, which print 1, right? This print 2, this print 1, this print go. And then this function return. This function return. And it return what is the countdown at this point. It return to this stack here. The countdown at this point is 1. That's why when I say print countdown, if I add this print countdown here, print count here, at this point, this function return. Now I go back to this layer. In this layer, countdown is 1. I print count. That's why you see 1 again. And then this function return, and I will go back to this layer. And this layer, the count is 2. That's why you will print 2. This is what we call the unwinding the stack. The function return, and you will go back to the previous function. This function return, you will go back to the previous function, the one that's calling it. Alright, so why don't we write a simple recursive function named printn, a message and n that display the message n times. So if I call printn hello world 3, it should display hello world 3 times. I know you can do that with the iteration. Can you do that with the recursion? So you can see the comparison. So what is a base case? When do you stop? Well, the base case would be 0, because if the n is 0, that tells me I should not print anything. Right? If n is 0, I should not print anything, do anything. So the base case should be when n is 0, you don't do anything. Otherwise, you would display the message and make the n smaller. So let's do that. Let's go to the exercise. Let me add a new file. I call it print n. So let's create a function called print n message n, and I will just say pass for now. And let me call print n. Let's say hello world. I put exponential point here. And let me go to the exercise folder. It doesn't do anything yet because the function doesn't do anything, but this is just setting up the skeleton code. So let's do the base case. If n is less than or equal to 0, I do less than or equal to 0 because I want to do 0, do nothing, but if n is negative, printing a negative number of message negative time doesn't make sense, right? So if n is 0 or negative, then do nothing, just return. Otherwise, I will print the message and let's make the problem smaller by making n, the second parameter, smaller. So now if I run this program, missing one, require, let's see, which line number? Line number 9, print n, message 3, and line 9, print n, file, line number 5. So line number 5 is error. This should not be print n, this should be just a print. So let's fix it. And this is a hello world 3 times. Hello world n time, I should say. The base case, the making the problem smaller and calling recursively calling print n with the smaller problem. This number gets smaller and it will hit the base case, and when it does, it stops the recursion. Thank you.